Okay, so chapter 8 continues, and we need to delve a little bit into set operations and compound inequalities. So we need set operations to set up some ideas here before we get to the compound inequalities. So sets are collections of objects. Now, for our purposes, the sets are usually going to be some sets of intervals for solutions, but we're going to practice without that at first. They're usually written in braces if they have discrete solutions, and they can be described listing members using inequalities or interval notation, which is what we're most likely going to do. The set that has no elements is called the empty set, and it can be described with this circle with a line through it. Now, there's two main operations we do with sets: intersection and union. So the intersection includes a limited group of elements that are in both set A and B. So intersection is, what do they have in common if you're intersecting two sets, or what do they share? If you think about the intersection of two roads, where they intersect is where they both share the same space. Now the union of two sets is really just a combination. So anything that's in one or the other gets thrown together all in one set. And you can think of union kind of like a partnership or a marriage. If one person has it or the other one has it, if you get married, now you both have the item to use. Some examples from 8.2 include: true or false, the union of the solution sets 2x plus 1 equals 3, 2x plus 1 is greater than 3, and 2x plus 1 is less than 3 is negative infinity to infinity. That's their way of saying that are all numbers that satisfy something that's greater than or equal to or less than 3, is that all numbers? The answer is this is true, because if we look at this, this is x is equal to 1. Here would be x is greater than 1, and solving here is x is less than 1. Are all numbers either equal to 1, greater than 1, or less than 1? Yes, everything's in one of those sets, so that is true. So here's some set operations. Let A be the set 1 through 6, B be 1 through 5, C is 1 and 6, and D is 4. B intersect the empty set. So remember, the empty set has nothing in it. It's empty. So they're asking you, what do B and the empty set share, have in common? Any numbers? None. So what is 1, 3, 5? Intersect nothing. It's nothing. So, and generally, any set intersecting the empty set is the empty set. B union C. So again, union brings two sets together. So you include anything in either B or C. If it's in both, you don't need to include it twice. So 1, 3, 5, and 6 are in one or the other or both. A intersect D. That's 1 through 6. Intersecting with just the set 4. So again, intersection, what do they have in common, or what do they share? They share the 4. And so that's how this generally works. We won't do too much with this. It really is for us to apply to multiple inequalities that we might come across. So two sets of inequalities are graphed below. Graph the intersection of the two sets. So if we look at the graph, this is all the numbers from 1 all the way up to infinity. This is all the numbers from 4 to infinity. So it wants to know what numbers are in both of these sets. So basically, if you're looking at a number line, it's which area is shaded on both parts. And if you look here, everything from 4 all the way up is shaded in both, so you get to include everything all the way up. Now, how does this look like in an interval? Let's talk about, for each compound inequality, give the solution set in interval and graph forms. I'm just going to do the interval form for now. X is less than or equal to 2. That's negative infinity to 2. X is less than or equal to 5. That's negative infinity to 5. And means in both. So what areas are in both? We know anything from negative infinity to 2 is in both. However, from 2 to 5 is only in the second set, so it's not in both, so we don't include it. So the intersection of these two, which is a little more clear from the number line, is negative infinity to 2. Generally, the intersection always gets smaller or the same size as the smallest one. And sometimes you have to solve it yourself. X minus 3 is less than or equal to 6. That means x is less than or equal to 9. X plus 2 is greater than or equal to 7. Subtract 2. X is greater than or equal to 5. So if we're looking at from this perspective, if you don't like this, looking at this perspective, let's talk about in words what's happening. What numbers are less than or equal to 9 and greater than or equal to 5? Well, that would be all of them that are greater or equal to 5, less than 9, anything from 5 to 9. So you can use the word sometimes as well to get here. How would this look interval-wise? From negative infinity to 9, intersect 5 to infinity, and it still gives you the same 5 to 9. Okay, x is greater than or equal to negative 2, or x is greater than or equal to 5. So or means that it's in one or the other, or both. This is our union. So union is what's in one or the other or both. Numbers that are in one or the other or both. So even though they share from 5 to infinity here, they don't share from negative 2 to 5 because the numbers between negative 2 to 5 are not in the second part. But as long as they're in one or the other, it doesn't matter. So generally the union gets bigger than numbers. So this is negative 2 to infinity. Okay, so let's talk about, we'll let you do 9 on your own. Let's talk about number 10 and 8.2, express each set in its simplest interval form. So let's talk about, you could have multiple intervals that you can possibly combine into one. So you have all the numbers from negative infinity to negative 1 combined with the numbers from negative 4 to infinity. So if we look at this from a number line perspective, you've got negative 1 all the way over to negative infinity. Here, negative 4 is to the left of negative 1, so we have negative 4 up to infinity. And it wants us to combine these two sets into one. So as long as it's in one set or the other, or both, it gets included. Now if I look at these number lines, it looks like every number vertically is included in one or the other. So sometimes when you combine two sets, you can get negative infinity to infinity, because every number is either bigger than negative 4 or smaller than negative 1. So that is possible to get all numbers as an answer. What about 3 to 6, union negative infinity to negative 2? If we look at the perspective here, we've got negative 2 all the way over. 3 starts over here. So I'm bringing these two sets together. What I notice about these visually from a number line perspective is they don't actually line up or have any overlap. So sometimes the sets can't be combined at all, and the original you were given is the most simplified form. So since these don't have any overlap, you keep the same numbers you had before. It's the simplest it can be. I usually put the lower numbers to the left though, and the higher numbers to the right. That would be my only suggestion to change, but sometimes they don't overlap. And that is all for 8.2.